So yeah, hello everyone. Yeah, it's great to be here. I'm Shelven from Phala Network. Oh, yeah. So I think this today I will just give a brief introduction on the Phala Network and what we are doing recently, and also it's very good to learn what everyone else is doing right now. So Phala is created from 2019, and at the first day of our beginning, actually, what we try to achieve here is to build a real decentralized TEE network. uh, I mean, like every node in the network should be TEE hardware, and every node should be come from the not from us, but from our community. So also we want all these TEE hardware to be managed by the blockchain. So this is how the story begins. And until now, actually now we have over 30K TEE nodes in our network. And this means actually now we are managed, actually all of them are SGX, and now we are adding support for multi hardwares. And now we are managing the world largest decentralized TEE network, which is really like, you can see its skeletons across all over the world. Yeah. And I think the core problem we have been realizing here is that although T is useful regarding its like performance and also like the implementation cost, so but T is not trusted. And actually, the root of the problem here is that it's about what's the root of trust of TE. And currently, like I mean, like it's this. I think this established for Intel SGX, Intel TDX, and also AMD SEV. Actually, all these the current T implementation is depends on some secret keys which is generated and stored in the hardware during the manufacturing. So this is the current root of trust because this key is then used to derive all these keys to like steal the T data and also like to use to sign the I report. So, but this is the problem because actually now you can see the risk that this root of trust can be, I would say, cracked. And I think this problem is even more important than the others vulnerabilities about TE because the others vulnerabilities, they can be patched with some upgrade, maybe in the firmware, in the microcode, and in the BIOS. But once a TE secret key is leaked, then this means this TE hardware cannot be used anymore because the attackers can just fake these hardwares using the leaked secret keys. So this is a problem. And also this leads to the other problem like the lack of service availability promise in TE. So this is what we want to do is that we try to replace the current hardware-based root of trust with a decentralized root of trust, which is on-chain and which is totally managed on-chain. So it actually is a hybrid system combining the smart contract and also the off-chain TE workers. So what we built now is first we have built the decentralized root of trust, which is totally governed by the on-chain console, and also it consists of multiple nodes. They share the same secret keys as the master key. We call them a gatekeeper. So they are currently the TE hardware with the higher security level, and now we are trying to update it to the MPC solution. So combining the MPC and TE, so actually we do not need to. I think the security level will be even better. So the second thing here we implement is that we have built the chain of trust, which is a key management system using the key derivation function. So based on this root key. So and now we support upgradable applications, and also we support different hardware. So now we support Intel SGX, Intel TDX, AMD SEV, and also TE GPU. And also I think when the autonomous TE is available, we are very glad to be the first for that as well. Yeah. So the third part is that we have implemented a co-processor solution. So we allow the smart contracts only if they are on an EVM compatible chain, we can allow them to offload some part of their computation to our TE workers. Yeah. Yeah. I'll quickly script this part. So because yeah, actually in our model we just not solely trust the hardware, so we use on-chain smart contract to govern them. And also, since the key management is standalone, it's outside TE, which means actually we support the migration for the application on different TE hardwares. So our key management service it determines like which TE hardware application can run on. So this means even if one TE hardware is down, we can safely like migrate the application to another ones. Okay, so there is already many security research on Phala. So I would say like Phala is now one of the TE network of the top security promise. Because until now, from 2019 to until now, so there is many accidents about TE. So Phala survived all of them, and also based on the security research, Phala is one of the best TE network of the top security promise. Yeah. So now actually things now we are beginning to support multi hardware. So a very important direction here is that we are supporting TE CPU. So and also we are supporting the AI model training on TE GPU. So this will be a very important use case for us to do now. Yeah. So also another things which we are doing right now is to build a TE SDK to simplify developers' cost to deploy the application to our network, to all the TE network actually. So because we think the Intel TDX is the real game changer here, because compared with SGX, the TDX totally removed the needs for you to change the code. So and what's our job is to make these things I think even more easier, because so TDX or although it didn't require like you to change the code, I think many developers they didn't understand TE. So we want to abstract out more details. So they do not need to know how to set up TE. They do not know all the security best practice for it. So our SDK should take everything for them. And this is a cooperation between Phala and Flashbox. So Flashbox has proposed the SDK called DStack. And I think now Phala is becoming the major contributor to it. So I think the good part for it is that it's not limited to the hardware on us. So no matter what kind of hardware, only if it's a TE and it's support TE primitives, I think there's a chance for the SDK to support that. So I think this will be a thing that benefits all the community. Yeah. So this is some recent work we have proposed. Like we have run the first performance benchmark on the TE GPU. So, and I think the result is very promising because we can see that actually I would say in the default setup of the current AI model, you can see that the overhead of TE is very low and it can even be just ignored. So I think this will be a very promising work, no matter for the TDX and also for the TE GPU. Yeah. Yeah. I think, yeah, that should be all from me. So I'm also very glad to hear the progress for the other team. Thanks.